Hello and welcome to everyone in physicsfire. Today we are going to do the next part of electrostatic potential and capacitance, and the topic name is relation between electric field and electric potential. So guys, if you will see here, electric field formula is what? KQ by R square, right? And then potential formula is what? KQ by R. Guys, suppose if you will start from here, electric field is in this direction, potential here, potential here, potential here. Let's take this point is A, this point is B, this point is C. VA, VB, VC. Potential will decrease in the direction of what? Electric field. So that we should keep in mind. Now let's see the relation between electric field and potential. Easy only, relation between electric field and electric potential, right? Okay, so this, if you'll see relation, what we are going to consider now, that uniform electric field. Uniform electric field is constant as well as what? Uniform. Suppose a charge Q is here, it is displacing delta x in this direction, right? Now we can say in this direction, obviously there will be a force, that will be electric force Q into E. But guys, whenever you are considering like the charge particle is moving in a uniform electric field and you want to find potential, one thing you will have to consider here, that kinetic energy is constant. Kinetic energy is what? Constant. There is no change in kinetic energy. Guys, think, if kinetic energy will change, then ultimately you are changing the velocity. If you will change the velocity, then the energy will be used to change in velocity. So you will not get the exact voltage. So you'll have to apply one force in this direction. That will be what? External force. That's it. So we can say we will find what? Work, small work. Smaller work is equal to F external dot what? Delta x. That is the distance, right? Acha. If it is QE is in this direction and external force is in this direction, opposite of that, right? So we can say minus of QE into what? Dot delta x is equal to what? dW. dW, what we can say? dW into what? Q. Q cancel out. So delta V is equal to minus of E dot delta x. Easy. Acha, mod of that, right? Okay. So now what we are going to see, let's see one numerical. E delta V is equal to what? Mod of E dot delta x, right? Mod of E dot delta vector. This is vector, right? Delta x. Now we are going to see what? Let's see one numerical. Suppose two plates are there. One is positive, one is negative plate. This is plus of 20 volt, and let's take V. We want to find here. The distance between them is 1 meter. If electric field is constant and electric field is 20 Newton per coulomb, then you are supposed to find what is the delta V. Guys, if you want to find delta V, E dot delta x minus E is how much here? E is how much? Let's take this 10. It will be easy. 10 into what? 1, right? Dot cos 0, anyway 1. Mod of delta V if you want to find anyway. So it doesn't matter at all. Delta V. So change, we can say 10 volt. Correct only, no? Why? Because here is 20 volt, here is what? It should be less than. Why it is less than? Because it is less than, because in the direction of electric field, we know electric field will be in this direction, right? In the direction of electric field, potential should decrease. That's it. So this is about what? E dot dr and the relation between what? Electric field and electric potential.